Hello, my name is Mike Avery from Cadence Design Systems, and I'm going to describe the always operator inside of SVA. This operator was not in the language at the first issue of the LRM in 2005. It was an addition from 2009 onwards. First, however, we must be clear upon what's meant by always, because it already exists in the Verilog language, which predated the system Verilog language reference manual. So be very familiar with this always block here, describing a procedural block. So this keyword always describes some clocking event and then some procedural code, as we can see there. So you're almost certain to have seen that before and used it. System Verilog introduced other kinds of uses of the word always in combination here with a keyword always comb. That's a way of describing combinational logic without having to describe a sensitivity list. However, we're not talking about those, so that was just to clarify what we're talking about with always. We're talking about always in SVA properties, so assertions. So if you've written any assertions before, this will look very familiar to you. Now, what you probably didn't know is that from the System Verilog Language Reference Manual 2005 onwards, you could have said that. Okay, so that already existed. That's implicit. So you don't have to type it, and people never did. It wasn't until 2009 where they introduced a always operator which creates a new property. So what that means is you can write a property that looks like this instead. So what this property says, and it happens to be an assumption used in formal, if we have A followed one cycle later by B, from the next cycle we require C to be true always, meaning forever. So that use of always is the always operator, which was only valid from the 2009 version of the LRM onwards. Now we'll talk about some practical example where this is useful, this additional always operator. So if we're using formal, we might have some liveness assertion that may fail because the inputs keep the design busy. So basically it's easy for the tool to falsify the property by correct design behavior. So there's actually nothing wrong with the design, it's just the failure to describe the problem correctly to the tool. So for example, we might have a DUT here and we write an assertion which says if I have a start, then S underscore eventually I get a done. Now some requests keep coming to this DUT here which keep the design busy, so it's unable to issue a done. So it's easy for the tool to falsify this, even though the design may be perfectly correct. So we have a start here, and the tool just keeps making requests, and therefore I don't get a done. The design can never actually catch up with the speed at which the inputs make a request. So conceptually the tool's driving these input requests here. So we've got to prevent that happening somehow. So our first inclination will be to write an assumption that does this. S underscore eventually, I must have a cycle where there is not a request. So that's what this property says. There must always be a future cycle where request is not true. But this doesn't solve that case because as you notice here the request is going up and down. So we're satisfying this property. So this property is satisfied if I have not request here, and so on. And yet I still keep the design busy so it can't issue a done. So that's a false failure. So it's not necessarily something wrong with the design, it's just we haven't described the problem correctly because this assumption isn't correct. We haven't done what we intended, which is to stop requests forever. So this is where always comes in. So our property now, S underscore eventually, and this is the keyword always. So always, there has to be a future where not request stays low forever. So S underscore eventually means this property here must happen at some future point, and the property is always not request. So this does the job now because it says here there must be a point, and this is the loop. So conceptually formal tools will just demonstrate infinity by having a loop here. So basically we go through this loop here and we return to this point and then we continue through the loop. So it's as if we copy and paste this yellow portion to the right hand side of a waveform indefinitely, i.e. for infinity. So that achieves something we couldn't do previously by using this always keyword. We can also use this in covers. So one problem you might get in formal is if you over-constrain a design, so it's not possible to view an infinite length waveform. And one way of checking for this problem is by writing a cover. So we say cover property always 1. Okay, so we're saying every cycle this is true. So this will only occur if we have every future cycle being true. There's actually now a automated check inside Jasper which will do a similar thing to this. So this is proving we can have an infinite length trace. What we might also wish to do is a variation upon that, which again uses always and another operator here called the follow by operator. So this weird looking operator here. So the hash hyphen and another hash is the follow by operator. And in the language reference manual defines this as being equivalent to this expression here, which is not intuitively easy to understand. Okay, so you can't actually replicate this in any other way. What happens here other than by writing that expression, which is, again, is very hard to understand and debug. So what this cover says is if I have A occurring, this is followed by always 1. So this proves two things now, which I didn't do before. It proves that A can occur, and it proves after that that it's possible to have an infinite length waveform. Okay, so here shows our infinite length loop here. So this yellow shaded portion part, we can see where the loop marker is. So this shows we go from cycle 2 to cycle 30 and then loop back again and repeat the whole thing. It's possible to repeat the whole thing over again, so we don't end up running out of cycles in effect. So this followed by operator, more detail is included in another associated video on the support site, so just search for followed by operator and you'll see a video explaining that. So I hope you found that useful, and thank you for listening.